Welcome to All This Math. This is Professor Parker, and today we're going to do a video that deals with exponent rules. Okay? Exponent rules are fundamental to our understanding of algebra and also fundamental to our use of calculus and other aspects of mathematics. Now, exponent rules can seem to be intimidating if we don't know the rules and we don't know when to apply the rule. But once you know the rules, there are about 6 or 7 of them maybe. And when you know how to apply them and where you should apply them and in what order you should apply them, then they're not so daunting, right? So let's take a look at this example up here. We want to simplify this fraction because at the end of the day, that's all this is a big fraction with a bunch of variables in it, a bunch of exponents in it, a bunch of exponents on the outside of the parentheses, exponents on the inside of the parentheses, and we want to simplify it. And the way we simplify it is by applying the different exponent rules that we know, whether it's the multiplication rule, whether it's the division rule, whether it's a rule I call the distributive exponent rule, whether it's the zero exponent rule, whether it's the negative exponent rule. No matter what the rule is, we're going to apply it. All right, but we got to know when to apply it and how to apply it. Another problem with the exponent rules is that oftentimes you have options in terms of which rule you can apply, and that's okay. But some people feel uncomfortable when they have options. Some people don't like options, right? They want to know one firm way to do a problem, and that's it. But that's just not how these problems are. You have different options. But as long as you know the exponent rules, you can apply the exponent rules however way you see fit. All right? So first, the instructions, again, are to simplify. But also, this is important too. No negative exponents. So that means in our final answer, we shouldn't have any negative exponents. So that means we're going to have to apply the negative exponent rule if we do end up with some negative exponents. So when I see a problem like this, I take a kind of an inventory of what I see. Like I said, it's a fraction. I see some negative exponents up here. I see a zero exponent, so I know what I'm going to do with that, right? That's something that kind of just jumps out at me. Oh, I see a zero exponent. Zero exponent rule. Everything that deals with that zero exponent turns into a positive 1. That's one thing right there. Then I see parentheses. I see this negative 2 out here. All right? So what I'm going to do first is I'm going to deal with this zero exponent. I'm going to do that first. I don't have to do that first, but that's just what I feel like doing, right? That's what I want to do. When you see problems like this, you will have options. You have the power to apply the exponent rule that you want to apply when and how you want to apply it. All right? I'm going to deal with this zero exponent. So when I deal with that zero exponent, my numerator is going to stay the same. 6a negative 2b squared over 7 times 1. And I still got my parentheses. I still got the negative 2. Now, question is, why does this become a 1? Or where did this 1 come from? Why does a to the negative 1 times c to the 0 power equal 1? That's called the zero exponent rule. Whenever you have an exponent of 0, everything that exponent is applied to becomes positive 1. It's just that simple. All right? It's just that simple. That's called the zero exponent rule. So everything inside these parentheses becomes 1. This 0 has nothing to do with this 7, though. Nothing to do with this 7. This 0 has something to do with everything inside of these two parentheses right here. So everything inside of here, don't matter what's in there. It don't matter what's in there. How big the number is, how small the number is, negative, positive, fraction, decimal, it don't matter. Everything's going to become a 1, a positive 1. All right? So now since I know that, next thing I'm going to do is I'm going to do something with this negative 2 exponent. This is what I call the distributive exponent rule. Meaning when I have an exponent outside of some parentheses, you take that exponent and you multiply it by every exponent inside the parentheses. Again, when you see an exponent outside the parentheses, you take that exponent and you multiply it by every exponent inside the parentheses. So I'm going to multiply it by this positive 2. I'm going to multiply it by this negative 2. Now, here's a very common error a lot of students make. They forget that 6 has an exponent also, right? It's not written, but it has an exponent. 6 has an exponent of positive 1. If no exponent is written, that means that the exponent is a positive 1. So 6, even though it's a coefficient and it's not a variable, it still has an exponent. 6 has an exponent of positive 1. So I'm going to multiply this negative 2 also by the positive 1. And I'm going to apply, so basically this 7, let me rewrite this just as plain 7, because 7 times 1 is 7, right? So similar to how this 6 has an exponent of 1, this 7 has an exponent of 1. So I'm also going to multiply this negative 2 by this positive 1. So again, what I call the distributive exponent rule Your textbook might call it something different, and that's cool too, but just as long as you know what you're doing. With the distributive exponent rule, I multiply the outside exponent by every exponent inside. And then this is what I get. So now I got 6 to the negative 2 power, a to the positive 4 power, b to the negative 4 power, and 7 to the negative 2 power. You got to know how to multiply your positives and negatives. You got to know those rules. You got to know how to play that game, how to multiply positives and negatives. You just got to, or else we can't apply the exponent rules the way we need to. Now, I'm still looking at this. I'm looking at what I can do. I want to get rid of all these negative exponents because the original instruction says no negative exponents. I want to get rid of these negative exponents. So this is how I do that. When you apply the negative exponent rule, you basically take the reciprocal of that term. The reciprocal of that term. So that means that everything that's upstairs, this is what I always tell my students for years. Everything that's upstairs goes downstairs that has a negative exponent. Everything that's downstairs that has a negative exponent will go upstairs. So check this out. So this 7 is going to swing upstairs. This 6 is going to go downstairs. And this B is also going to go downstairs. Now, where does the A go? That A don't go nowhere. You know why? Because it don't have no negative exponent. If it's got a positive exponent, don't mess with it. Leave it alone. If it's got a positive exponent, let it chill. Don't mess with it. Leave it alone. All right? So the a to the 4th is going to stay in the numerator. The 6 is going to go downstairs. The b is going to go downstairs. The 7 is going to go upstairs. All right? So now, what's it going to look like? Now, the whole purpose of doing this is so now my exponents can become positive. Keep that in mind. What's the purpose of doing this? The negative exponent rule enables you to change your exponents to positives because we can't really use exponents unless they're positive. We can't use a negative exponent. We can't use it. We can use positive exponents. So we have to do something mathematically in order to enable us to use the exponents. We have to make it positive. So now when I write this, now I got in my numerator, I got this 7 came up. I'm going to write 7 squared. The a to the 4th was still there. It didn't move. 6 squared, 6 to the negative 2 goes down. Now that's a positive 2. B to the negative 4th goes down. Now that's a positive 4. All right. So now I got all positive exponents. And now I'm going to just simplify what I can. Right? So now I got 7 squared. Now keep in mind, 7 squared is not 14. You're not doing 7 times 2. That's a very careless error a lot of students make. Right? They look at the exponent and they say, oh, 7 times 2. Sometimes they're just working too fast. Sometimes they're confident. They know what they're doing. They're moving too fast. Right? Sometimes you got to slow down and chill for a minute, you know, and be consistent and be steady. Say, okay, 7 squared, that means 7 times 7. Not 7 times 2, 7 times 7. All right? So 7 times 7 is going to give me 49. And then I got 8 to the 4th. Then in my denominator, again, 6 squared. It's not 12. 6 squared is not 12. It's not 6 times 2, it's 6 times 6. 6 times 6 is going to give me 36. And then I got b to the 4th. And then I take a step back, I look at it, and I'm like, okay, you size him up, right? You size him up. On your paper, you size it up. You say, okay, well, what can I do now? Have I done everything I can do, or can I do something else? It don't look like it's nothing else you can do. We can't reduce 49 over 36 because they don't have a greatest common factor other than 1. So we leave 49 and 36. I mean, they're both perfect squares. Some people sometimes think, oh, well, they're both perfect squares, so let me simplify that. Let me reduce that. You can't necessarily do that just because they're perfect squares. They don't have a common factor. A to the 4th in the numerator, b to the 4th in the denominator. There's nothing else to do. This is going to be your final answer. All right? So we got 49 a to the 4th over 36 b to the 4th. All right? Now, again, we have to learn the exponent rules. We have to learn. It's like 6 or 7 of them. Like I said, it's like, and in this problem, we didn't use all of them. We didn't even use all of them. You will have problems where you got to use all of them. But in this particular problem, we didn't even have to use all of them. We used a few of them. Make sure you know the multiplication rule, the division rule, the rule I call the distributive exponent rule, right? Some books call it the power rule or the power of a power rule, right? The zero exponent rule, make sure you know that, and the negative exponent rule, which we use right here. All right, so what's that like? That's like 5. That's like 5 joints, right? All right, yeah. It's not a whole lot to memorize, but you got to memorize it, and you got to be able to look at a problem and pull out like, okay, what am I going to use, and where am I going to use it, and in what order am I going to use it in? All right, because you have options. You know, like I could have did this problem a different way, right? I chose to, you know, use the 0 exponent rule first, right? Change this to a 1. That's why I got 7 times 1 right here, which became 7. What I could have did is I could have used the negative exponent rule just with that -2. I could have flipped everything upside down, and then this would have became a +2. And then I still would have had to use the distributive exponent rule, right? But you see what I'm saying? I just want to point that out because I want to let you know that, like, when you're using exponent rules and you're simplifying expressions with a lot of exponents in them, you have options. You have options. And it's going to be up to you to figure out what rule to use and when to use it and how to use it. All right? So my recommendation to you is to, like, tackle a lot of problems like this so you can become more familiar with how to use the exponent rules, knowing what the exponent rules are, and when to apply them and in what order and in what situation. All right? So please like the video. Please subscribe to the page. Please share the video. And as always, remember that there's all this math all around you. Peace.